Okay, I think we're good to go now. Yes, I think we're almost set to run. Right, I think we're good to go. Good evening once again. You're on to Mamu with Jarvis. This is the Midnight Sun Project. This is the Midnight Sun Project. The Midnight Sun Project is a project, it's a special project of the mathematics multiverse, Mamu Jarvis, trying to reach out to students who will be writing JS3 exams and SS3 exams. The whole idea is to take the work little by little and be able to put together a wealth of resources that can help students to go over. But some students just like to learn on their own. Some may want to not bother getting private teachers, whatever. But this is more like a community project geared towards ensuring that students properly revise for the exam. And if you're a fan of the Marvel Cinematic Universe like myself, you will know that today the Black Panther Wakanda Forever is premiering, and something close to my project, I heard something about the Midnight Angels. Wow, that's something interesting. So even Wakanda Forever is trying to copy into my project. And I know the Marvel Cinematic Universe also has a project called the Midnight Sun. Let me not bore you with all those details. Today, we hit the road with what we know how to do best. And today we're looking at geometry. Maths is in 3 realms here: arithmetic, algebra, and geometry. So for geometry tonight, we'll be looking at circle geometry part 2. This is not Wakanda Forever. And we'll be looking at arcs, chords, and cyclic quads or quadrilaterals. We solve some questions. Like I always say in the introductory notes of this video, that our focus is to solve more questions so that you are able to build your confidence as you prepare for the exam. So we'll go straight away to business and see how we can get ourselves better at solving maths. All right, I'll start off by looking at, what year is this now? November 2006, WAEC, November 2006 OBJ. Now, something I do before my class, and that's why you really need to watch my videos very well and look out for Easter eggs and mistakes. I try as much as possible not to prepare before solving these questions. I've had a lot of people query that, but for me, it's not about trying to prove that I can solve. It's more about trying to be in that exam environment and see how well my brain can work. I read, I do my revisions, but when it comes to solving problems in this setup, I always like to come in without having gone through the question paper. So if you're able to spot an error, it means that you understand the concept now. That's really my check. It's a litmus test for showing that you've understood the concepts. Once you can spot my flaws, it means you're understanding the concept, and it's an intentional act from me. All right, so we start off by looking at November 2006 OBJ, and we will start by looking at question number 21. Question number 21. Please, if you're watching from YouTube, you are free to drop your chat. If I'm too fast, drop the chat. I'm also monitoring what I'm doing through the YouTube channel. So if you feel I'm too fast, please, there's an idea that is not clear, just drop them there. I will always attend to the chat. But it's one of the reasons why we take this short break to calm ourselves down. So I'll look at the chat. If there are areas that I need to readdress, I'll come back to look at them. All right, so we look at question number 21. And as is the practice, I'm going to draw. Right, and I have what is called a cyclic chord. A cyclic chord is a quadrilateral inscribed in a circle. A cyclic chord is a quadrilateral inscribed in a circle. So if we use the edges of a circle to form a quadrilateral, that quadrilateral will be a cyclic chord. So I have LMON. That's what I'm giving. I have this to be 2y minus 20. I have this to be y plus 50. I have this to be x, and I have this to be x plus 60. Now, there are rules for solving this, and for cyclic chord, we are told by way of deduction that the theorem says that opposite angles of any cyclic chord is what? Supplementary. So that's the idea we need here. So I can say that 2y minus 20 plus, I put in bracket just for purpose of emphasis, plus y plus 50 is equal to 180 degrees. I don't have enough space here, so I'll just put that on. Now, what's the reason? Cyclic chord. Cyclic what? Chord. Right, so I'll add them up. This becomes 2y minus 20 plus y plus 50 equal to 180 degrees. So what does this give you? I'll add the 2y and y, that will be 3y. Negative 20 plus 50 will give me what? Negative 30, or rather plus 30, because that will be 50 minus 20, and that will give me 180 degrees. So what's the next thing I do? It means 3y will be equal to 180 minus 30, and 3y will be equal to 150 degrees. So y will invariably be equal to what? 50 degrees, once you have done your division correctly. So y will be what? 50 degrees. So if that is understood, we now try to look for x. So by that same measure, x plus 60 plus x plus 60 plus x will give me 180 degrees. What's the reason for that? Some books will say opposite angles of what? Cyclic chord. Opposite angles of cyclic chord. Maybe I should just increase that here. Opposite angles of cyclic chord. Chord is a short form for quadrilaterals. So quad is a short form for what? Quadrilateral. So with that done, I'll have that x plus 60, purpose of emphasis, will be equal to 180. And then I can add this to 2x plus 60 equal to what? 180. Then I can have that 2x will be equal to 180 minus 60. If that is understood, it will mean that 2x will be equal to what? 120 degrees. So if I divide both sides by 2, x becomes what? 60 degrees. But be careful here. The question says find x plus y. What is x? 60. What is y? 50. X plus y will give you what? 110 degrees. So for that question, the answer will be what? 110 degrees. So I'll give you some time to catch your breath. All right, so we're done with that question. So that's all for that question. So you discover that because modern maths is more of less like a Cambridge pattern, you really don't do too much here. You really don't do too much. You just need to know the principles to use per time. And if you apply them correctly, you get the correct answer. All right, so we're done with that. And we'll try to go to another. I'll leave this just for purpose of emphasis. And I think that same year, I have another one, question 25. And in 25, in the diagram, O is the center. So I'm going to draw the diagram. And then this is O, that's the diagram. And sorry about that. All right, so this is O, this is Q, this is T. There's another point here, something like this. This is R, this is P. When they intersect, this is S, capital letter S. This is connected to this, and this is connected to this. I'm told that this whole angle here is 120 degrees. And I'm told that this angle here is 39 degrees. Now the question says, in the diagram, O is the center. O is what? The center. Now, angle SRQ is 39 degrees. And angle ROST is what? 120 degrees. We are told to find angle RPT. Angle RPT. And this is the angle we are told to find. So I'm going to call this angle X. Because there's a way I solve problems like this. We'll simply say using notations as in diagram. This method I'm using, you wouldn't find it in math textbooks. I came up with this method because I discovered students find it very difficult to deal with too many. I've tried using this method, and sometimes a lot of the students get even more confused. So I came up with a very simple technique. Instead of that, why not just assign letters? I write a statement using notation as a diagram that implicates the examiner. Is bound to look at it. Is bound to look at how I'm solving the question from my own world, from my own brain. So using the as a diagram, I will just fix letters to places I feel I will need. Now I'm going to call here X. I'm going to call here Y. Because remember, I'm to look for what? ROPT. Now, look at that very carefully. If I know this now, please, I'm just mentally looking at this problem first. Because sometimes before you present your work, mentally assess the problem. If I know this, I know this. Because if you watch carefully, let me connect here so you see you have a perspective to what I'm doing. PQ is a chord. PQ is a segment. Part of taking my grade 11. This is more like the first year I'm officially taking grade 11 class, and it's been an experience because I'm able to bring in my own paradigm or my own dimension to teaching this topic. Now, I came to understand where students get a bit confused. PQ is a chord. What's a chord? A chord is any line connecting opposite sides of the circumference, but does not pass through the center. What it does is that it divides the circle into two segments. So if a line is dividing the circle into two segments, that line is likely, that straight line, emphatic, is a chord. But beyond that realm of being a straight line, there is another function PQ performs. It is a function called segment. And a segment is a shape. So a segment is a portion of a circle bounded by a chord and or rather an arc. When we come into majoration proper, you begin to see some of these explanations. But how does that relate to solving problems here? And look at it. This segment PQ is going to produce one triangle in this direction and another triangle in this direction. It creates a concept under arcs, chords, and cyclic chords we call same segment. If I have two triangles in a circle originating from the same segment, the angles they form on the circumference of the circle will be equal. So what that means is this: if this chord or this segment PQ is projected like this and like this, the angle that will be formed here and here must be equal. So I'll say Y is equal to 39 degrees. What's the reason for that? Same segments. The segments are the same segment, and for most of emphasis, I'll say same segment PQ. Same segment is just enough, but we never can tell what the marking scheme will look like. So I'll say PQ. I'm referring to segment PQ. So once I know this one, the next thing I want to do is to try to find, I found this. Now, the next thing I'll try to do is to try to find what? X. Now, look at this. X plus Y is equal to 120 degrees. X plus Y is equal to 120 degrees. Maybe I should take a line back so that you understand what's happening here. Now, look at this. Consider triangle PST. PST. You observe that X plus Y will be equal to 120 degrees. The opposite interior angles must give you the exterior. So we say what? Exterior angle of what? Triangle what? PST. Just all these are just written to help my examiner know the direction I'm going. In some marking scheme, they wouldn't check for all of those details. All right. Now, I know Y to be what? 39 degrees. Is that not? So it will mean that X plus 39 degrees will be equal to 120. So X will now be equal to 120 minus 39 degrees. And the answer becomes 81 degrees. 81 degrees. Wow, I hope I'm right. Why is my head telling me that there's something amiss? Okay, let's hope that what I've done is correct. All right, so okay, there's an answer like that there. So I will trust that what I've done is correct. So the answer is what? 81 degrees. And I think with that, we can say we have solved the two questions in that year. I'm done with that. So I can pick another question paper. All right, so let's pick another question paper. This time around is a theory question paper. This time around, it's what? A theory question paper. All right, so let's look at this. It's in question. What year is that? That's 2002. WAEC. November 2002. Question number theory. That's question 4B. Question 4B. So I'll try to draw the diagram on the board. And I have a center here. And connecting that center is R and P. Then from this center also called O, I have another line protruded like this, come to a point S. Now, this line is parallel to this line. Let's adjust that thing a little more so that it looks real. Right, so this is connected. And this is also connected. So this is Q. I think that's the diagram we have on the board. And this angle is what? 58 degrees. So the diagram says, in the diagram, the question says in the diagram above, POR is a diameter. POR is a diameter. Okay. And arrow Q is parallel to SO. Arrow Q is parallel to SO, right? And arrow PQ is 58 degrees. Calculate what? I thought to calculate two angles. Arrow OS, that's this angle here. So let me call it X. And we're told to find angle arrow PS. Arrow PS. Arrow PS. Okay, I need to connect this point. Sorry about that. So I define arrow PS. That is angle here. I'll call that Y. Now, look at this very carefully. Because this is produced from the center, because this is produced from the center, remember that for radar, this is a radius, is equal to this, another radius, and is equal to this, another radius. So we have radius from the origin, sorry about that, OR, OS, and OP. So they are all radius, or radar as it were. Now, what am I looking for first? I'm looking for ROS. 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 Okay, so how do we obtain ROS? So we look at the diagram very well, because sometimes questions like this will require that we look at the diagram. Let's see, ROPS. Fine. I have an idea of what to do, but I want to be sure that I want to avoid getting the second one first. But in the exam setup, if you get the second one first, it's not a problem, provided your method is intact. So let's look at this. This angle will be 90 degrees. Now, if this is a diameter, the angle that will be produced here must be half of it. And if this angle is 180 degrees, because angle is 180 degrees, it means that what this one will produce here will be what? 90 degrees. So in writing, I'll call this, let me call this Z. So I'll say using notations. As in diagram. Z is equal to 90 degrees. And what is the reason for that? Very simple, semicircle. That's what you need to write. If this is a diagonal, sorry, a diameter, the angle that this will form, the angle the diameter, sorry, forms with respect to the circumference will be what? 90 degrees, always half of it. So with that said, Z becomes what? 90. And hence I've gotten Z, I can easily get this angle. But the question I'll ask myself now is that, is this angle relevant to what I want to get? Because remember that what I'm interested in getting, let's watch, what I'm interested in getting is actually this angle, ROS. I'm interested in getting what? ROS. So let's watch. Now, I've gotten Z. So let me get this one. Let me call this one A, small letter A. And I'll tell you why getting that A is very important shortly. Now, let's watch carefully. Now, A plus Z plus 58 will be equal to 180 degrees. What's the reason for that? A plus Z plus 58 degrees equal to 180. This is a triangle. So it is angle sum of triangle what? RQP. Now look at this, or you can say PQR. PQR. No matter how you name it, most important is that you follow the order. I can say PQR, I can say QROP, I can say what? ROPQ. Order is very important. So look at this one. Look at this triangle. That's what I'm going to have here. This is 90. So I have A plus 90 plus 58 equal to 180 degrees. So A plus 100 and is that 48? Right to that. We give you 180. And A will be equal to 180 minus 148. A will be equal to 32 degrees. A is essentially what? 32 degrees. So with that, another important property from you see, although this is called circle geometry, you discover that sometimes your ability to remember rules from other parts will help you in solving them. Now, I've gotten A. If you look at this, RQ is parallel to SO. So look at this angle here. This angle must be equal to this angle. And what's the relationship? It is called alternate angle. So I can say that X is equal to what? A. And the reason is what? Alternate angles, what? RQ parallel to SO. RQ is parallel to SO. So for that reason, this angle here will be equal to X. And we call them alternate angles. What do you call them now? Alternate angles are called F angles or Z angles. Okay, Z angles actually. All right, so with that, X will be equal to 32 degrees. But remember, we're not told to find X. It's I who said that X is equal to what? ROS. So I will tell my examiner that what? ROS will be equal to X, and that will be equal to 32 degrees. And that solves that one. Now, the next question I'm told to find is to find what? Y. If this is Y, this angle will obviously be what? Let me call it another letter. Let me call it B. So now look at this triangle PSO is isos. Why? Because OS is equal to what? OP. And what's the reason for that? It's read that OS is equal to OP, and the reason for that is that it is what? Read that. This is a radius, this is another radius. So if that is said, I can say that what? B is equal to Y. And the reason for that is what? Base angles of what? Isos triangle. The base angles of isos triangle will settle that relationship. So if that is understood, with that, I can go ahead to say that what? B plus Y is equal to X. Why? Opposite interior angle is equal to the what? Exterior. So the reason is that what? Isos triangle, let me be specific, PSO. This may not really matter, but just to help you when you're revising to know the triangle I'm talking about. Now, B plus X plus Y will give me X. What's the reason for that? Exterior angle of what? Triangle PSO. All right. So with that settled, I can say that what? If B and Y are the same, I can say that my focus is to find Y. I can settle to say that Y plus Y is equal to X. What is X? 32. So 2Y will be equal to 32. And Y will be equal to what? 16 degrees. So if that is done correctly, it means that the answer will be what? 16 degrees. But remember, we're not told to find where. Why? We're told to find angle ROPS. ROPS. I hope you know that ROPS can also be OPS. So for purpose of emphasis, I will say that what angle ROPS is equal to angle what? OPS, and that is equal to Y, and that is equal to 16 degrees. For purpose of emphasis, so when you're revising, you can see angles that are related and know how to handle them. So that takes care of that question. I will move to something else. All right, so we have another theory question, but let's just catch our breath a little. Okay, so let's go to the next one. So this one is from WAEC, November 2011 theory. And it's question 4A. So we'll try to draw the diagram, which is usually your first responsibility in questions like this. And this is a diagram. It passes through the center. This is O. This is so this angle here is 48 degrees. And then we're told to find, then in the diagram, O is the center, OC is parallel to AD. OC, line OC is parallel to line AD, okay? AB is a straight line. AB is a straight line. AB is a straight line, obviously passing through the center, and OCA is 48. So I'll close this part. Right. And I'm told to calculate angle ABC. ABC. So this angle I'm told to find X. Let me call that angle X. And then from this, you discover that OA, OC, and OB will all be equal. They are radii. So they are pointing, they are drawn from the center, so they will all be equal, right? Now, I don't know, let me just put a Y here. I don't know if I'll need it, but let's just put that Y there. A, B, C. This is the angle I'm looking for. So I need to know this angle too. So I'll put a small letter A here, because if I know this angle, I already know this one. Because triangle OAC is actually what? Isosceles, so that an isosceles triangle. All right, is there another information that can help us? Okay, now something very interesting. If I get this angle, I'm told to look for phi. If I get this angle, and I have this angle, and I have this angle, I can find this one. All right, so let's start. I'll start by saying in triangle AOC, comma, or triangle AOC. Okay, let me start by saying using notation as a diagram, using notations as in diagram, using notations as in diagram, we'll have that what? Triangle AOC is isos. So it's an isos triangle. As such, A will be equal to 48 degrees. That will be these angles of what? Isos triangle, right? So if that is understood, ABC, let me check ABC. All right. So if that is understood, y plus 48 will be equal to 90 degrees. This is a diameter. So this is a diameter. If this is a diameter, I'm told that AB is a straight line. So if it's a straight line, it's passing through the center, it is a diameter. So they're trying to test your understanding of that. So this will be equal to 180 and 90, and that will mean what? Semicircle. So with that, I can have that y will be equal to what? 90 minus 48. And y will be equal to 42 degrees. So I know y, I know a, so I can get x. All right, so I can get x. So I can say that x plus y plus 48, and this will be 90, plus a will be equal to 180 degrees. And what's the reason for that? Angle sum of triangle. Angle sum of what? Triangle. So I know this is 90. The whole of this is 90. And I know a to be 48. So I'll say x plus 90 plus 48 to be equal to 180 degrees. What does that give you? That will give you x plus 138 equal to 180. X will be equal to 180 minus 138. And that will mean that what? X equal to 42 degrees. Wow, that's an interesting one. And I hope you know why that is correct. I hope you know why that is correct. Because this OCB is another isosceles triangle. But remember that we're not told to find x, we're told to find what? Angle ABC. So angle ABC will be equal to what? 42 degrees. Always emphasize that at the close of your problem. So let's take a little break to rest, and then we'll come back to look at that. Look at another problem. Okay, so just take a little time to just cool our brains, and then we go to more questions. Okay. All right, so let's go to the next question. Let's see what this question will afford us. All right, so let's clean up and let's clean off everything and we proceed. Right, so oops, wrong marker. Okay, we have this is a WAEC, actually WAEC 2019, if I'm right. Yeah, so this is WAEC 2019 OBJ, and the question says question 43. It says have a circle like this. This is coming like this. This is coming like this, and I'm told that this is 90 degrees. We're told to find y. This is 35 degrees, and this is 90 degrees, and it's labeled M, and this is PR. So we're told to find the value of y in the diagram. Now you're told that this is 90 degrees. So what I'll do is to try to look at this triangle, this part of the triangle. So I'll call here, let me call here A, because I need to get this to be together. So I'll say that what? A plus 90. So I'll start by saying what? Using notation as in diagram, using notations as a diagram. Using notation as in diagram, I'll have that A plus 35 plus 90 will be equal to 180 degrees. A plus 35 plus 90. Anytime you see this sign, it means 90 degrees. So A plus 125 will be equal to 180 degrees. What will A be? It is 180 minus, this is positive, a king crossing over becoming a slave. A will essentially be equal to 55 degrees. Now, remember that what we're told to find is what? Y. Now, there's a relationship that says A, Y will be equal to A. Remember, if you look at these segments, let's say N, sorry, this should be M, sorry about that. I told you that this line is both a segment, even though it's not drawn, you can actually draw it. MN is actually a line. I can also be a segment. So Y is equal to A, meaning that what? Same segment. They are originating from the same segment. So as such, Y will be equal to 55 degrees. That takes care of that problem. So Y equal to 55 degrees will take care of that problem. Okay. y equal to 55 degrees will take care of that problem. Okay, so we try to take on another now. Try to take on another. So we go to another year. This one is WAEC, June 2014. WAEC, June 2014. So let's see what that year had in stock for us. Now notice that in solving this, what I've tried to do in solving this, what I've tried to do is to look away from other aspects. There's another aspect that they call tangent, alternate segment, some other of those concepts. I've not gone into those areas. I've tried to restrict it to the first area of this circle theorem or geometry that talks about arc to chords and to cyclic chords. So that's where I have limited my operations to. All right. Okay, so we quickly try to look at that. The diagram, we'll try to draw the diagram now and see how that pans out for Ross. Okay. Let's see how that pans out for Ross. Okay. So let's see how that pans out for us. Okay, so the diagram in question is something like this, question 41 of that year, and it's this. Looks more like maybe to call it a cyclic kite, if there's anything like that. Right, so this is equal to this, and this is equal to this. Right, so this is 80 degrees, and this is M. And we're told to look for M. Now, what we know before now is that for cyclic chords, they are what? We expect that for cyclic chord, they are what? Supplementary. That is, sum up to the opposite angle, sum up to 180 degrees. So if I were to look for this angle, if I call this X, I'll be able to get this angle. Now, we'll look at something very interesting. If you remember your kite very well, you remember very well that if this angle is M, this angle must be M also. If this angle is M, this angle must be M also. Now let's go back to our kites. If I draw a kite like this, this angle must be equal to this angle. This angle must be equal to this angle. It's only these angles that will not be equal. But this angle will be equal to this angle. So you discover that sometimes in solving problems, the properties you can remember would help you deal with the problem decisively. So I would say that what? Using notations as a diagram, M plus M is equal to 180 degrees. So I'll call it one cyclic, opposite angles of what? Cyclic chord. Somebody can use another method. Somebody can decide to use another method. That's fine. But you understand that in an exam setup, you don't have the luxury of time. So if 2m is equal to 180, m will essentially be what? 90 degrees. So here, your knowledge of your knowledge of kites becomes important in getting your final answer, and cannot be otherwise. Cannot be otherwise. So that will settle that aspect for you. That will settle that aspect for you. So m will simply be what? 90 degrees. Okay, that settles that question. Because the other questions don't really relate to that for much of what it was. Okay, so we will try to look at what I may call the last questions for tonight, so that we can all retire to our beds and have a wonderful night's rest. Okay, so this will be WAEC 2021. So WAEC 2021 objectives. Now, let's see, there are questions before that. We look at question number 37. Question 37. That's what this is what the diagram looks like. There's a center O, and both lines pass through the center. So both lines pass through the center. This is what? 65 degrees. Now, if both lines are passing through the center, it says what? In the diagram below, PQ is a diameter. PQ is a diameter. Is a diameter of the circle. PSQR, fine. Now, with center O. Okay, so sorry about that. Okay, with what has been said, it will mean that possibly I'm only told that PQ is a diameter. So PQ is a diameter. So it will pass through the center. Now, I'm told to find this angle. So let me call it X. PQ is a diameter. So if PQ is a diameter, we know that means this angle here must be what? 90 degrees. If PQ is a diameter, then angle PSQ will be what? 90 degrees. So I'll call all of this Y. Okay, now to get this one, I need to get this one. So let me call this Z. Are you with me? To get this one, I need to get this. So from the diagram, using notation as a diagram, using notations as in diagram, I can infer that what? Y is equal to 90 degrees. What's the reason for that? Semicircle. Y is equal to 90 degrees, and the reason for that is that what? It's a semicircle. So now Z plus 65 plus Y is equal to 180 degrees. What's the reason for that? It is an angle sum of triangle what? PSQ. I'm just doing this for emphasis sake, so when you're revising, you understand how we're getting some of those things. Now, if that is done, I know Y to be 90, so Z plus 65 plus 90 will be equal to 180 degrees. So Z plus 155 will be equal to 180 degrees. So Z will be equal to what? 180 minus what? 155, which means that Z will be equal to what? 25 degrees. degrees. But is that where the question ends? No. If Z is equal to 25 degrees, then it means that what? X will be equal to Z. X will be equal to Z. What's the reason for that? Look at SQ, segment SQ, generating two triangles and two angles on the circumference. So the reason for that is what? Same segment. Same segment what? Let's write that on under. So that will be same segment. Same segment SQ. So X will now be equal to 25 degrees. And that solves that question. Right. So we just have one more question to go. So let's be patient. One more question to go. Just have one more question to go. So one more question to go. All right, so let's try to draw the diagram. So what here is that? That will be Y, or rather NECO. So this is NECO. 2021. Okay, I stated that. Did I say YX? Sorry about that. It's not YX, it's actually NECO. Sorry about that. It's NECO 2021. So, take from that year, this is question number 38. So sometimes you can go back, look for the question paper, and figure out how some of these things are done, right? So this is what the diagram looks like. The intersect at X, and this is K, L, N, N. It's a strange one. We already named like that. No problem. So this is 40 degrees, 80 degrees. I'm seeing a stroke there, which means that may be the angle I have to look for. And I'm told that in the diagram below, MKLN is a cyclic chord. LKMN. And the diagonals NL and KN, their diagonals, they bisect at X. All right, so let me close them up. Let me close the figure up because the cyclic chord. Now, we're told to calculate MLK, angle MLK. So where's MLK? MLK. This is the angle I'm told to look for. Now, if you look at this diagram very well, we may have solved the problem already. So I'll call here X, I'll call here Y. So I'll say using notations, as in diagram. Remember, before I start solving, I must have a clear idea of what I want to achieve. Now, to get this one, I need to get this. So if you look at that, Y is equal to 40 degrees. Y is equal to 40 degrees. Now, look at this segment. It's generating this one. It's generating this one. I say that this segment is generating this triangle and generating this triangle. So I'll say this word, same segment. I'm going to emphasize the segment so that you can revise that later. LN. Is that okay? So if y is equal to 40 degrees, then what is x, which I'm looking for? X plus y is equal to 80 degrees. Opposite interior is equal to exterior. So I'll say exterior angle of triangle what? KXL. KXL. I seen that. All right. That's sorted out. I need to look for x. So x will simply be what? X plus 40 will be equal to 80, and x will be equal to what? 80 minus 40, which means that x will be equal to 40. But remember, you are not told to look for x. It is you who assign that thing to be x. So you must tell the examiner the angle MLP is equal to x, and that is equal to 40 degrees. So that settles that problem. Wow. So take a minute or two to catch your breath, and then we'll close out. So I want to trust that today's class was very helpful to you. Wow, thank you for those of us who are staying on. Also do the honors of sharing this channel. Share. There are people who are in great need of mathematics. I'm always happy when I hear students don't pass maths. So share it, share it. People have great needs. So share this and let them take out time to look for us, and we're trusting that as we keep on the activities on this channel, this year's exams will be something. When I mean this year's, I'm talking about this session exam, will be something you will look back on. Thank you very much. The Midnight Song will return next week, Monday. I'll try to do it. I'll try to send the schedule early so that you can prepare yourself for what to expect next week. Till I reach you again, it is Mamu Wijabe saying, Wakanda forever.